Hi students, welcome to this session on spanning set of a vector space. So let me explain this with a lot of examples. Let us start. If every vector in a given vector space V can be written as a linear combination of vector in set S, then S is called the spanning set of the vector space V. So the concept is very simple. What is the meaning of this concept? Right? So span means what? With given vectors, how do you form vector space? That is what span means, right? So here you see, if you have if every vector in a vector space V, right, can be written as a linear combination of vectors in set S. That's what I'm telling here, right? So what's the meaning? Let us start. Right? Okay. So span of a set. Yes. This is what we are going to see. Spanning set of a vector space. So span of set S can be written as simply span S. So this notation you must know. Span S means span of a set S. Right? So what is that? I will explain in detail. Let us assume if S is equal to V1, V2 and Vn. This is a set. S is a set of vectors. Yes or no? S is a set of vectors. Vectors is nothing. Here the vectors are V1, V2 up to Vn in vector space V. If S is a set of vectors in vector space V, then what is the meaning of span S? Then the span of S is the set of all linear combination of vectors in S. So span of S is nothing but a linear combination of vectors in S. So whenever we say linear combination means it is vector addition and multiplication. Vector addition and scalar multiplication. That we must remember, because in the vector space itself we studied it has involved two operations. So linearity means it should have a vector addition and scalar multiplication, right? For example, what is the things? I want to find span as S is equal to span S, we know V1, V2 up to Vn. This is what our S, right? S. So span S means span V1, V2, set of V1, V2, Vn. If that is, what is the meaning of this span set of V1, V2, Vn? That is nothing but span of S is the set of all linear combination of vectors. What are the vectors in the S? V1, V2, Vn. Linear combination of this vector is nothing but, I told it is scalar multiplication and vector addition. C2, V2 up to Cn, Vn. Here you see all the vectors are added, V1, V2, Vn. So V1, V2, Vn are added. Vector addition is there. Second, you see these vectors are scaled by a scalar. So scalar multiplication is there. The vector is multiplied by a scalar. So this is what a linear combination means. So span S is nothing but this is, if S is a vector, S is a set with a V1, V2, Vn, span S is nothing but C1, V1, C2, V2 up to Cn, Vn. That is, it is nothing but the set of all linear combination of vectors in the S. What are the vectors in the S? V1, V2, Vn. I write as a linear combination of these vectors. That is what span means, right? So here you see I have written everything. So you see what is the difference between see S has only V1, V2, Vn. Span S means all the combinations of all the permutation, all the combinations of these vectors, linear combination. That means add these two vectors, that will also form a span. For example, you see v1 plus v2 is a span of v1 v2. If you are having a two vectors, a span v1 v2 means you add like this, right? Or otherwise 2v1 plus 3v2. You put any combination, or 0v1 plus 0v2, or v1 minus v2 plus anything you put for that. So that's what linear combination. That c1 c2 may take any value, clear or not, from minus infinity to plus infinity. That means if you find all the values and get the total combination, that is called span. That's what I told. With the given set, right? How do you form a larger space? That is what span means, right? So you see, what is then why should I study the span? Is ensures that the span of vector space ensures that, for example, the set spans V ensures that S has enough material, enough vectors to build V. That's what I told, right? So with minimum whatever, with given vectors, we can form a vector space. So S has enough vectors, right? If you are able to form, I can form V. That's what set spans V indicates, right? So that is what very, very important. I can write, see, the notation is very, very important. Span of the vector set, where set will give vector space V, right? So with the given set of vectors, I can build a total vector space. That's what span. So this has enough material, right? Okay. Similarly, I can write this span as, I can write as S spans V. That means S generates V, right? Or I can write as V is spanned by S. That means V is generated by S, right? Or S is a spanning set of V. Spanning set of V. All are indicating the same meaning. Span as V means S spans V, or S generates V. V is spanned by S, or S is a spanning set of V. All are having the same meaning. So what we understand from span? Span means if you are able to write a given vector as a linear combination of other vectors, then that is called span. That's what I am telling here, right? So linear combination means you should be having vector addition and scalar multiplication. Whenever you have addition and multiplication, I told it is a linear combination, right? So please understand that concept. Here you see, I told if every vector in a vector space can be written as a linear combination of vectors in set S, then S is called a spanning set of vector space V. That means S has enough vectors to build a vector space V. That is the first thing we must remember. That point is very, very important, right? So set spans V ensures that the set S has set S, right? Set S has enough vectors to build a vector space V. I write as build a vector space V, right? That's what, see, if for example, we have sugar, milk, water, right? So these are all the, for example, yes, the set may be a sugar, milk, water, and tea powder. Let us assume this is a set S. Span S means what? By using this, you can generate a vector space called T for any numbers. right? If you are able to give a T, serve a T for a whole population, then this is called span-S, right? By using the linear combination. For one person, you put small amount of sugar. For n person, you multiply, you scale the sugar value, right? For 10%, you scale equivalent to that. Similarly, you add that much of milk. Clear or not? So by using the given raw material, what are the maximum thing we can form? That's what span-S. Are you understanding the logic? So if you have a minimum, for example, 10 milligrams sugar, sorry, 100 milligrams sugar, 2 liter milk, and 5 glasses of water, and 100 gram tea powder. By using this, how many tea you can form? That will coming under the category of span-S, right? So what the total amount of tea formed is called vector space V. Right, so by using this much of quantity, you can form a T to minimum 5% and maximum you can form, for example, let us assume you can form for 20%. Clear? So that 20 is called spanning set. That means all the linear combination, right? You have to put in all the linear combination what is the maximum thing you can generate. That's what spanning set. I hope you understand the concept. If you have any doubt, please ask me in comment section. I will clarify. Thank you.